So both A and B division, both only 25 students are present. Four, five, six, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. 20 members only. A division. Okay, we'll start. Screen is visible. Anyone? Please reply.
Yes, sir, visible.
Okay, thank you. So in the previous class, we have discussed about the Hayes Bridge and one more, which one it is? Hayes Bridge and Anderson's Bridge we have discussed for the measurement of self-inductance. So for the measurement of resistance, we are going to use Kelvin-Whitson bridge and Kelvin-Double bridge. For the measurement of inductance, we are going to use Maxwell inductance bridge, Maxwell inductance capacitance bridge, Hayes bridge and Anderson's bridge we have discussed. So now we'll go towards the capacitance measurement here. So the resistance measurement is over, inductance measurement is over. So now we'll shift towards the capacitance measurement. According to your syllabus, they have mentioned 2 bridges for the measurement of capacitance. Okay, total they have mentioned 2 bridges. That is called, one is DeSauty bridge, another one is Shering bridge. These 2 bridges we are going to use for the measurement of capacitance. We are going to use here. See here, this is the bridge circuit. This is the bridge circuit. 4 arms are there: AB, BC, CD, and DA here now. So the first arm that is connected here in between AB, that is called C1, capacitor 1 is connected, and BC resistance 3 is connected, and the fourth one, that is R4, is connected, and second branch, that is DA, that is called C2, is connected here now. C2 is connected. Some people, they have joined now. Okay, so here the C1 we have to measure here now. We have to measure the value of C1, we have to measure here now. So C1 is the unknown capacitance, C2 is the standard capacitance, R3 and R4, these two are the non-inductive resistances here. Non-inductive resistances we are going to consider here. So the voltage drop across the capacitor C1 is nothing but that is called E1. Voltage drop across C2, that is called, that is E2, and voltage drop across resistance R3, that is called E3. Voltage drop across R4, that is called E4. E4 we are going to call here. So what we will do, first we will start to draw the phasor diagram. Okay, here because of the AC supply, the current I will start to flow here. First the current I will start to flow here. At this point, some current will flow here, some current will flow here. So current flowing through the capacitor 1 will consider as I1. Current flowing through the capacitor 2 I will consider as I2 here now. So same current will flow if the bridge is balanced. On that condition, this detector will be null detector. So it is 0 here. So the same current I1 will flow here through R2, and this one R3, R4, the I2 will flow here now. So if there is no detector at all, then the circuit will be like this. one capacitor, one resistance. These two are connected in parallel. This is a parallel circuit जैसे हो गए? Yes or no? If there is no any detector here, no, I have given the supply to this one. I have given to supply to this one here, no. Yes or no?
Yes, sir.
So under this condition, if I am going to take I1 and equal to I2 here, no, I will consider here I1 I will consider and here I2 I will consider. The value may be changed, but here also capacitor resistance is there. Here also resistance capacitance is there here. So suppose if I will consider, just a minute, I will consider I1 and I2 as a reference here. No, I will consider somewhere here I1, I2 I will consider. Here I will consider as I1 here. Whatever it may be, both are in phase only because both are connecting, having a same load, RC load and RC load here. I have taken the I1 and I2, I have taken reference here now. Okay, next I will erase everything, just a minute, to understanding purpose. So I will consider here that is called I1 and I2. I will have taken common here now. The reference point I have taken here now. I2. Next, the current I1 will start to flow here. So voltage drop across the capacitor, that is called E1 we are going to call. So for the capacitive load, voltage lags the current or leads the current? पूरा ब्रिजेस सर्किट में मैंने नियरली आई थिंक 8-10 बार पूछा है, एक भी आंसर नहीं दे रहे. Nobody has given answer for that one. Every time I am telling, every time you will forget that one. For the capacitive load, the current lags or leads?
Lead.
Current leads the voltage. So the voltage drop across this one is E1 here. No, current leads means it should be upper side. So downside we have to take, that is 90 degree. 90 degree we have to take here now. I will take that one, that is E1 I will take here now. E1 I will consider here. Next, same current will flow through this one here now, through a resistance. Voltage across the resistance and current here now. For the resistive load, what will happen? Both current is leading or lagging? For the resistive loads,
In phase.
in phase. Very good. I have not given the option, then also you have given the answer. It is in phase. I will write here, that is called E3 here now. I will write it is in phase, that is called E3 here. So this part is over. Next, come to this part. Here current I2 is flowing here now. So I2 and 1 by omega C2, that is called E2 will get here now. So V2 here also capacitive load is there. For the capacitive load, current voltage leads the current or lags the current? Voltage lags the current. So both are same only. Either क्या पूछा मैंने, current leads the current voltage or lags the voltage पूछा. The reverse पूछा, voltage leads the current or lags the current, means voltage lags the current. So same again here, E3, E2 will also come here because same are there. Here also capacitor, here also capacitor. Next here resistance is there, again it is in phase. So we can say that one E3 equal to E4, we can say that one. E3 equal to E4. So for that reason, in between, I will draw the voltage, that is net voltage supplied by the source here now, AC source here now. So this one I will join here, the dotted line, and I will join by a dotted line here, like this. So this is the phasor diagram. Already they have drawn in the printed matrix, they have drawn, then also have drawn. We have with current flow, we have considered that one. Any doubts? Any doubts you have? Is there any doubts? I am asking to you people only. जब तक तुम आंसर नहीं देते तब तक मैं आगे नहीं जाता फिर. I'm asking to you people, so if you have any doubt, you can ask. Otherwise, you say no. Roll number 10. B division roll number 10. Are you there? I will call one time, second time, third time. If you not reply, I will put absent. Roll number 10, I will put absent only. Then only will understand. This is the value of interaction. Roll number 6.
Yes, sir.
What I am asking? You have any doubts? Roll number 6, I am asking to you only. You have any doubts?
No, sir.
Then why you are sitting silently? You have to give the answer, na? Huh? I told you people to give the reply at least. Any one person, nobody is giving the reply means why I would have to conduct the lecture. I will stop here only and I will discuss with HOD then. ऑफलाइन में आके क्लास करो तुम लोग, सब मालूम हो जाते तब. So the phasor diagram formation is over. Now what we have to do, according to the Wheatstone bridge, we know the formula for the balance condition. Row number 6 again. According to the Wheatstone bridge, what is the formula for balance condition? Maxwell bridge I will consider. Roll number 8. Sonal. Roll number 8. Roll number 8, Sonal. Last time I am calling. Number 10. Roll number 8. Absent. Roll number 9. Roll number 9. B division roll number 9, Kartika. 9 also absent. Formality के लिए ज्वाइन किए तो क्या फायदा है? Roll number 8 and 9. Once again I am asking you peoples. Try to give the reply. I will remove you from the meeting. Then you will understand that. Remote roll number 8, 9, roll number 10. Are you
Yes,
there?
sir.
Can you tell the formula under balance condition for the AC bridges? What is the formula?
ऍक्च्युली सर मी डिप्लोमा CO मधून कंप्लीट केलाय सर, त्यामुळं मला ह्यातलं एवढं काही जास्त माहिती नाही.
Diploma?
कम्प्युटर ब्रांच मधून कंप्लीट केलाय मी सर.
मैडम डिप्लोमा कौन सा भी रहने दो ना, बट अभी इतना ब्रिजेस डिस्कशन करने के बाद तो मालूम होना है ना आपको.
सर एवढा लगेच सर डोक्यात बसत नाही हे सब्जेक्ट.
तुम उसके लिए प्रैक्टिस करना पड़ेगा, फिर बहुत मुश्किल है फिर ये.
Yes,
मैथ्स
sir.
और ये सब्जेक्ट इट इज नॉट दैट मच इजी. You have to prepare. When you will prepare, when you will understand, when you will start to interact. अभी मैक्सवेल ब्रिज में कौन सा सर्किट यूज किए? What is the formula for all the bridges? We have used two formulas only. For the DC bridges, we have used R1, R4 equal to R2, R3. Yes.
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 For the DC bridges, just a minute, one more. Who is that? Roll number 8 and 9. I will not accept roll number 8. उनको कोई तो कॉल किया तो बोल दो उनको. मैंने एडमिट नहीं करने वाला हूँ उनको रोल नंबर 8 को. Number 18 is joining now. Roll number 2 is joining now. Okay. So R1, R4 equal to R2, R3. For the DC bridges, we are going to use this. For the AC bridges, this resistance is replaced by impedance. So in the place of R, we have to write Z1, Z4 equal to
Z2, Z3.
Z2, Z3. That's it. It's a common hai na abhi. This formula only I am asking from you people, but nobody is giving the reply. So we know that Z1 and Z1, Z4 equal to Z2, Z3. But to write the equation, no need about the, what is that? Computer science, electrical does not matter here. Now, this is the basic concept here now. This is the basic concept. The basic concept, you know that one, X equal to 1 by omega C. X equal to 1 by omega C. XL equal to XL equal to omega L. आपको उसके लिए डिफिकल्ट होते बोल के मैंने स्टार्टिंग की यूनिट चैप्टर होने से पहले एक्सप्लेन किया नहीं. I have explained or not this all the things. This one, what do you mean by Z? Z equal to R plus JX. Yes or no? R plus JX. We have already explained these all the things. For the capacitive R plus AX, for the inductance, for the capacitive R minus JX, you can write that one. Okay, so now unnecessarily not wait, I will move towards the writing the equation of Z1, Z2, Z3, Z4 here now. So what we have to write? Listen, roll number 10, you listen carefully. The Z1 is this one, A to B, it is Z1 we are going to consider here. What is the value here? Which is there? It is capacitance is there. Is there any resistive part here? Roll number 10. और कौन-कौन है computer science का?
Yes, sir.
Only roll number 10. Other peoples? और कोई है क्या? CSE का कौन है?
नहीं.
Roll number 10 hours?
12.
Roll number 10 and 12. Okay. Listen carefully. Roll number 10 and 12. You right? Concentrate here now. Is there any resistive part here? See, circuit diagram. You remember circuit diagram. Is,
Capacitor part is, sir.
huh? Capacitor.
C1 is capacitor part.
Okay. C1 is only capacitive part is there. Okay. There is no resistive part here.
Ha.
Yes. So actually Z is nothing but Z equal to R plus JX is there. Yes. R plus JX is the formula. Yes or no? Plus or minus I will consider. R plus or minus JX is the actual formula for the impedance here now. This Z plus or minus. Okay. Listen carefully.
Yes,
So
sir.
you have to reply. I say reply देते रहो. Okay. आप लोग क्या करो? What you do for inductance, Maxwell bridge or Hayes bridge, Anderson bridge, DeSauty bridge, Shering bridge, you have to remember this formula Z1, Z4 equal to Z2, Z3. And for the Whitson bridge and Kelvin double bridge, you have to remember only R1, R4 equal to R2, R3. Okay. Later R1 का value लिखने का, R2 का लिखने का. अभी इधर Z1, Z2, Z3, Z4 value लिखने का ही थोड़ा difficult. It is some a little bit difficult for you people. If there is no resistance part at all, see only capacitance part is there. So capacitance part, how we are going to write that one? It is XC1 we are going to write this one. Instead of C, it is we will consider in the form of reactance we are going to consider this one. This XC1 is this part we are going to consider as XC1 we are going to consider here. XC1. The resistance part is 0. So resistance is 0 minus JXC1 we can write like this here. The formula we can write R is 0. So Z1 equal to R is 0. I will write 0. The capacitor part is there minus JXC minus JXC. एक एक्सप्लेन करता हूँ एक बार अच्छे से ले लो. कैपेसिटर है तो माइनस J यूज करो डायरेक्ट. Okay. So XC equal to what? Previously I have told XC equal to 1 by omega C. Yes or no? XC equal to 1 by omega C. XL equal to omega L here. So XC is capacitive reactance here. No, this is capacitive reactance. XL is inductive reactance. XL is inductive reactance. Rule number 10 and 12. समझ में आ रहा है?
Yes, sir.
Okay. So here JXC. Now 0 का term रहने दो अभी. I already in the yesterday class I told here you people 1 by J equal to minus J I told. वो याद है? 1 by J equal to minus J.
Yes, sir.
Okay. So here minus J is there. Instead of this minus J, can I write 1 by J? Minus J का प्लेस में मैंने 1 by J लिखूं? Yes? Yes or no?
Yes, sir.
Okay. कौन रिप्लाई दे रहा है अभी? What is your roll number? Yes, कौन बोले अभी last?
Roll number 14.
Roll number 14. What about roll number 10 and 12? Roll number 10 and 12. You have to unmute.
Yes, sir.
वो
Yes,
दोनों
sir.
unmute करके बैठो अभी.
Yes,
Hmm?
sir.
So
Yes, sir.
in this place of minus J, वो कहाँ गए वो? पूरा उड़ गए क्या? This place of minus J, I can write 1 by J. ऐसा लिख सकते? I have told here the formula is there 1 by J equal to minus J. So here minus J का place में मैं क्या लिख रहा हूँ? 1 by J I am writing here. Yes?
Yes, sir.
Next, XC is there. In the place of XC, can I write here 1 by omega C? This part. Yes? So 1 by omega C here now. 1 by omega C. So total, we can write this one as 1 by J omega C, we can write. J1 by omega C is nothing but C1. Capacitor C1 I will write here. First branch we are considering. You can write like this. Roll number 10 and 12. अभी भी कुछ doubt है तो बोलो मेरे को. Now
Yes, sir.
this is the last concept of the third unit. वापस ये chapter हमने study नहीं करने वाला है. If you have any doubts, now only you clarify. Late होने दो, but you have to, your doubt should have to clear.
Yes, sir. No doubt.
No doubt. So if
No doubt,
only
sir.
capacitor is there, C1 is there, directly you have to write Z1 equal to 1 by J omega C1 लिख सकते. This is for understanding this. All the steps, whatever I have taken, that is just for your understanding. Okay. Z1 equal to 1 by J omega C1. Next, Z2 equal to, roll number 12, you tell that one, Z2 equal to what? Z2 equal to how we can write? Roll number 12.
Yes, sir.
हाँ, Z2 कैसे लिख सकते हैं फिर अभी? डायरेक्ट आंसर बोल दो मेरे. कंपेयर विद Z1, C1 और C2 के प्लेस में क्या डिफरेंस क्या है देखो. This is Z1. This one is Z1. This is Z2. This is Z3. This branch is Z4. I am asking, I have written already Z1 का formula. I have written Z1 equal to 1 by J omega C1. Z2, can you tell me the formula for Z2? Roll number 12. Monica madam.
Yes.
हाँ बोलो, Z2 equal to what? Speak out. कुछ तो बोलो एटलीस्ट. गलत होने दो. Don't worry about that wrong answer and all the things. First try to speak out. It may be wrong, it may be correct. Wrong हो गई तो मैं explain करने के लिए हूँ इधर.
Hello, sir.
हाँ बोलो मैडम.
मैं बताऊं?
हाँ आप बोलते मेरे को मालूम है, बट रोल नंबर 12 का आंसर चाहिए मेरे को.
So 2 upon JW C2.
1 upon
JW upon JW C2.
JW upon JWC2. How you are taking JW?
Sorry.
What is this one here? Is there any listen, for that reason only I am telling rule number 12. You listen carefully here. So Z equal to actually for the capacitive load R minus Jx we are going to write. Okay, R minus Jx. This X is nothing but net reactance we are going to call. Here इधर क्या है capacitor है ना? Yes. 12 unmute करो. Roll number 12.
Yes, sir.
Only capacitor C2 is there. So instead of X, I will write XC2 here now. XC2 I will write. Is there any resistance part here? Resistance part है क्या इसमें?
नहीं.
नहीं है. So resistance we can remove that one here. इधर क्या बचा है अभी? माइनस जे बचा है. माइनस जे का प्लेस में मैंने 1/j लिखूं by using this formula. Minus j equal to 1/j.
Yes, sir.
1/j I can write here. Next, XC1. XC1 is nothing but that is XC only, na? XC equal to 1/omega c we can write. Huh? XC equal to 1/omega c. Here XC1 है 1/omega c1 we can write. Sorry, XC2 है 1/omega c2 we can write.
Yes, sir.
1/omega c2. Now दोनों कंबाइन करके बोल दो इक्वेशन. इक्वल टू व्हाट? इधर 1/j है into 1/omega c2. What we can write?
1/j omega c2.
1/j omega c2. That is the correct answer. That is the correct answer. Next, आपके लिए ये क्वेश्चन है. Can you tell me what is the formula for Z3? Z3 को बोल दो अभी.
1/j omega c3.
Where is the Z3? Here Z3 is there. C3 है क्या इधर?
R3. Sorry, sir. R3.
हाँ बोलो अभी आंसर बोलो. Yes.
R.
R.
R3.
R3. Very good. Next.
Is equal minus
R3. R3
minus
minus
XC3.
XC3. Okay. Next. That is the mistake you are doing here now. Here, is there any capacitive term is there here?
No.
No, then R3 plus or minus 0. R3 plus or minus 0. So that is nothing but R3 plus or minus 0 is nothing but R3 only we can write directly. Z3 equal to R3, na? Then roll number 10. Can you tell me the Z4 formula?
Yes, sir.
Z4 equal to what?
Z4 is equal to R4 minus 1 upon J
minus 1 upon J
into 1 upon omega R4.
Omega R4.
How
you are writing this formula? Is there any capacitor term here?
No, sir.
Then why you are taking this minus j omega term and all the things? If it is inductor capacitor term is there, then only the x term will come. Otherwise, it will be 0 directly. समझ में?
हाँ.
इधर कैपेसिटर टर्म नहीं है, इंडक्टर टर्म नहीं है. So Z3 equal to R3 डायरेक्टली लिख सकते हैं आप. ओके. इधर भी कैपेसिटर टर्म नहीं है. Z4 equal to R4 only. The answer it will come only R4 here now.
Okay, sir.
So don't expand all the things over there. See here there is no resistance term and all the things. There is no resistance term. Roll number 10 and 12. You are from which place? Roll number 10.
So morning.
Yes, sir.
हाँ, कहाँ से है आप? गांव का नाम बोलो.
Mada.
Mada and roll number 12.
Morning.
हाँ?
Morning.
ठीक है. If it is offline session, you come to college and once you clarify your doubts. So इतना explain करने के बाद भी still you are in doubt. You are not easy method follow नहीं कर रहे. There is no capacitance inductance. Directly you write Z3 equal to R3. If the capacitor or inductors are there, then only the X term will come, that is complex term will come. It indicates that whatever your answer I am listening, that one you are poor in mathematics. You have to improve your mathematics. Okay. Only for this subject and mathematics, it will become difficult for you. So, according to this, listen, again, once again, I will ask that one, rule number 10. Now, you tell the Z1 formula here. Z1 equal to what? See here, this term here, A to B, this is Z1 here now. This is Z1. This A to D is Z2. ओके दोनों एक एक आंसर बोलना चाहिए मेरे को अभी. Z1 Z2 रोल नंबर 10 एक दे बोल दो, जो रोल नंबर 12 एक बोल दो फास्ट. अभी ऑलरेडी लिख के मैंने इरेज किए फास्ट. अनम्यूट रोल नंबर 10 and 12.
Z1 is equal to 0 minus
Very good. 0 minus
0 minus JXC
JXC1. Okay.
is equal to
Is equal to
1 upon J
1 upon J
into 1 upon omega C1.
1 upon omega C1. Very good. That is 1 by J omega C1 here. Now, directly we can write here. Next, roll number 12. Very good. Very good. Roll number 10. Have grabbed the knowledge. Roll number 12.
0 minus
0 minus
JXC2
JXC2
is equal to 1 upon
1
J,
upon
J omega C2.
J omega C2. Very good. So by writing this one, Z1, Z2 we have written, Z3 equal to, there is no complex term at all. So Z3 equal to R3 we can write directly, and Z4 equal to R4 we can write directly, because there is no inductive and capacitive part over there. So after writing Z1, Z2, Z3, Z4 and formula, we have to substitute Z1 and Z2, Z3, Z4 value in the above equation, that is Z1, Z4 equal to Z2, Z3 here. Either substitute karo this formula. Here Z1 value substitute, here Z4 value substitute, here Z2 value substitute, here Z3 value substitute here. So I will take the next slide. Already we have written this one here. See here. At balance condition, we know the formula, that is this one is Z1, this one is Z4, this one is Z2 and Z3 here. Substituting Z1, Z2, Z3, Z4 formula. Here Z1 kya hai? 1 by J omega C1 we have substituted. Z4 equal to R4 we have substituted. Z2 equal to 1 by J omega C2 we have substituted. Z3 equal to R3 we have substituted. Now what we have to do? This one we have to do, or we can write that here also J omega is there, here also J omega is there. We can get cancel this one. So this once again in the simplified form we can write this formula. I will write here now. See here. इसको क्या कैसे लिख सकते हैं? R4 divided by J omega C1 equal to J omega C1 equal to R3 divided by J omega C2. J omega C2. इधर J omega दोनों कैंसिल कर सकते हैं हमने. There is no addition term and all the things. Only ये जैसा इक्वेशन आपको बोलता हूं मैंने, x by 4a equal to y by 4b. ये 4 कैंसिल कर सकते हैं भी. इधर का 4 कैंसिल कर सकते क्या? नहीं. ठीक है, अभी भी कंफ्यूजन में है तो I will write one more method, easy method. I will do that. Next, क्या करो? This j omega c1 you send into RHS side, it will multiply into R3, and this j omega c2 you send into LHS side here. So we can write this one as R3 j omega c1 equal to j omega c2 R4 here. j omega c2 R4. इधर j है, ओमेगा है, j ओमेगा. अभी कैंसिल कर सकते हैं एटलीस्ट?
Yes,
or no?
sir.
अभी कैंसिल
Yes,
कर
sir.
सकते हैं. Okay, j omega get cancelled here now. R3 C1 is there here now. So I will send this R3 into again RHS side को भेज देता हूँ मैं. C1 equal to C2 R4 divided by R3 लिख सकते. ये C1 as it is LHS side लिखा है, ये R3 है ना. I will send into this RHS side, it will become denominator now here. C2 divided R4 divided by R3 here now. So same formula they have written here. C1 equal to C2 R4 divided by R3. Yes?
Yes, sir.
Yes, sir.
What is our question here now? Measurement of what we have to measure? Unknown capacitance here now. This the capacitance. C1 is nothing but capacitance only. Yes?
Yes, sir.
C is nothing but capacitance only, na? So we can write this C1 is, we can use as an unknown capacitance, or C2 we can use as an unknown capacitance. Anyone can you tell me what is the formula for C2 equal to? Same equation use करके C2 का formula लिखना है मेरे को. How will tell? Write that one. C2 equal to what? Yes. A C2 equal to C1 as it is लिखो. C2 equal to C1 as it is लिखो. इधर R3 है ना, इस साइड गए तो ये C1 को मल्टीप्लाई हो जाएगा. So R3 divided by this R4 इधर डिवाइड हो जाएगा. R4 will divide into C1 here now. So divided by R4 here. Yes, correct है? C2 equal to C1 R3 divided by R4. Correct है क्या नहीं?
Yes, sir.
So like that, rearranging the equation and all the things, you learn it. Who is the other background student, only computer science student, you have to learn this one. So little bit आपको ये समझ में नहीं आ रहा तो दिन मशीन का कैसे है? How you are understanding machine? We'll discuss later. Okay. So you concentrate on that one. At least you have to remember the last formulas. Okay. So this one same procedure is there for all the equations, all the circuits. Only Z1 Z4 equal to Z2 Z3. पूरा थर्ड यूनिट में एक ही फार्मूला रिमेंबर करने का. दो फॉर्मूलाज R1 R4 डिवाइड बाय R2 R3. DC के लिए, AC ब्रिजेस के लिए Z1 Z4 इक्वल टू Z2 Z3. ये फॉर्मूला रिमेंबर करो and you have to know how to write the Z1 Z2 Z3 equation. You have to how to write that one. You have to know that one. So that completes the DeSauty bridge. We have found the equation for that one. Next we will go for the Shering bridge here. Now see a Shering bridge. This is very interesting actually for you peoples. Here the Z1 is combination of resistance and capacitance is there. Z1 is combination of resistance and capacitance. Z2 has only capacitance. Z3 has only resistance. And Z4 has resistance and capacitance, both are in parallel here. Both are in parallel. Already we have derived this equation here. So two resistances are in parallel means R equivalent equal to R1 R4 R2 equal to R1 plus R2. ऐसा लिख देते हैं. दोनों रेजिस्टेंस पैरेलल में है तो ऐसा लिख देते हैं. Okay. Same thing we have to use R1 into X divided by R1 plus X here now. For the capacitance we can use here R1 plus X. By dividing this one, so in the place of X it may be capacitance or inductance here. We can use that one based on that. So before starting this one, I will explain the phasor diagram here now. See here, the current I will start here now. The current I1 will flow here and I2 will flow here. See here, the I1 current is flowing through only capacitor 1, but I2 current is flowing capacitor C2 and C4. Two capacitors. So both I1 and I2 not in phase here. No, I2 current has two capacitors. I1 has only one capacitor here. No, so I2 leads the I1 by some angle here. Now for that reason, what I have taken as I1 as reference here. Now I2 I have taken some for some leading angle. We have taken I2 here. Okay, is it clear? I2 we have taken. Next, what we have to do? The I1 will start to flow here now. So voltage drop across this one is I1 divided by omega C1 here now. Voltage drop across this one is I1 divided by omega C1. We can write here now. So that one, which is voltage lags the current by 90 degree here now. Lagging means what you have to do in the anti-clockwise direction. I1 आगे रहने का, lagging means we have to take downside. That is called I1 omega C1 here now. I have taken here now. 90 degree I have taken here now. 90 degree है ये. Okay, next R1 is there here now. Voltage drop across this R1 is I1 R1, which is in phase with the current I1 here now. So I1 R1 we have taken here. Next I3 R3 we have taken here. I1 R3, it is also in phase. One part is over here. One part is over. Next part, what you have to do? Here C2 is there, where the current I2 is flowing into C2 here. Here the I2 is there. So the current leads the voltage 90 degree. Now I2 को हमने 90 degree backside लेना है. I will clear this one. I2 is here. I2 is here. So from I2 to 90 degree, it should have to lag here now voltage here. So current I2 leads 90 degree by an voltage. दोनों को 90 degree है अभी इधर से इधर. Yes, the voltage is this one, current is this one here. Next, the voltage drop across R4 equal to voltage drop across C4 here now, because both are in parallel condition. So voltage will be same for the parallel circuits. So directly we'll consider IR R4 here now equal to IC divided by omega C4 here. This part we are going to consider here. So in between this I1, I2 and all the things, both the I1 and I2 currents are in capacitive currents. So the voltage E, it will comes here now. The total voltage lags the current I1 and I2. We can say that one. I1 and I2, we can say that one. So it is a phasor diagram formation. So now the task is that who want to tell, we know the formula. Again, we are going to use the same formula, that is Z1, Z4 equal to Z1, Z4 equal to Z2, Z3. Z1, Z1, Z2 equal to Z2, Z3. We are going to write here. So anyone, can you tell me Z1 formula? ये दोनों बोल दो, ये दोनों को रहने दो. Only Z1, Z2 you, any one of you. Especially roll number 12 को पूछता हूँ मैं अभी. Same question. Roll number 12. Now you tell me the Z1 formula. परफेक्ट होना है तो आंसर दे दो मैडम. डरो मत सर, मेरे को ही पूछ रहे बोल के ऐसा डरो मत. डोंट हेजिटेट, यू विल गेट द कॉन्फिडेंट लेवल. आपको ही कॉन्फिडेंस ज्यादा होने वाला है आंसर बोल दिया तो. ट्राई करो, बोलो अभी आंसर बोलो. Z1 बोल दो. Z2 नहीं चाहिए मेरे को. दिस इज Z1. Z1 equal to, I have written already Z1 equal to. Don't waste the time. Try to give whatever comes. कैसे आते हैं ऐसा बोल दो आंसर.
C1 R.
हाँ?
C1 R1.
C1 R1. Rule number 10.
यस सर. डायरेक्ट बताओ क्या, स्टेप बाय स्टेप बताओ.
डायरेक्ट बताओ, डायरेक्ट बोल दो.
1 upon J omega C1.
J omega C1. This is Z1. Here step by step बोलो अभी. ठीक है, रोल नंबर 10 स्टेप बाय स्टेप बोलो।
0
हाँ, 0 क्यों है?
कैपेसिटर पार्ट है इसलिए।
इधर रेजिस्टेंस पार्ट भी है ना, कौन बोल रहे हैं रेजिस्टेंस नहीं बोल के? इधर रेजिस्टेंस पार्ट नहीं है क्या? इधर रेजिस्टेंस है ना,
हाँ सर है।
तो फिर क्यों व्हाई यू आर यूजिंग 0 देन?
सर
प्रीवियस प्रॉब्लम देयर वाज नो रेजिस्टेंस एट ऑल, इधर रेजिस्टेंस था क्या? कुछ नहीं है, उसके लिए 0 यूज किए। नाउ हियर द रेजिस्टेंस पार्ट इज देयर इन द सेम ब्रांच, so you have to write in the place of 0 you have to write R1 here now. R1 minus R plus 1 by j omega C1 here, 1 by j omega C1 here. Yes?
Yes.
So roll number 12. At least try to give the answer of Z2.
0 plus
0 plus
1 upon
1 upon
j omega C2.
j omega C2. Very good here. So Z3 equal to directly R3 will get. Z4 equal to, we have derived this equation for the Maxwell inductance bridge. I will not explain once again. Directly I will go for the answer here. So it will take another 20 minutes time again to understand you people. So here I have written Z4 value directly as here Z1 equal to, I told that one, R1 plus 1 by j omega C1. This one is Z1. Z4 equal to R4 divided by 1 by j omega C4 R4 here now. Z4 equal to R4 divided by 1 plus j omega C4 R4. Z2 equal to 1 by j omega C2 and Z3 equal to R3 here now. Direct we have used here now. And we have substituted in the formula of Z1 Z4 equal to Z2 Z3 formula को हमने substitute किया है already. We have substituted in this one here. Now what we have to do, what I will do here now is after substituting this one, here this is one term, I will keep here only, and this denominator term is there, that one I will send into RHS side, it will multiply into 1 here. 1 plus j omega C4 R4 is there, I will send into RHS side, it is going to multiply here now. So what you will do, the left term is R1 plus 1 by j omega C1 is left here as it is, ऐसे ही लिखा है. इधर R4 है, R4 भी ऐसा ही लिखा है. R3 divided by j omega C2 पहले ही है, ऐसा ही लिखा है. This multiplied value I will write here 1 plus j omega C4 R4 here. This is RHS side को आ गया अभी. Is it clear? इधर तक clear है? This only this part I am sending into RHS. Okay. So next step what we have to do, we have to multiply this R1 into here, R4 equal to here. Okay. Then this R3 j omega here and this one here. By splitting the terms, we are going to get the value here R1 plus j omega C1 R4 equal to R3 j omega C2 1 plus j omega C2. Previous equation as it is liya hai. Now what I will do, R1 into R4, I have written as it is, plus j omega, sorry, this one they have taken 1 by j को ऊपर माइनस j लिया है, उसके लिए माइनस j ऊपर आ गया. इधर समझ में आ रहा है क्या? इधर देखो, इधर वन स्टेप, हियर 1 by j है, दिस वन 1 by j को माइनस j लिख सकते, ये साइन माइनस कर सकते. सो फॉर दैट रीजन दे हैव कंसिडर्ड हियर माइनस j. ये R4 मल्टीप्लाई किया, R4 इधर आ गए, ओमेगा C1 एज इट इज ओमेगा C1 लिखा है. इक्वल टू टर्म दे हैव रिटन हियर आल्सो 1 by j इज देयर, सो 1 by j का प्लेस में माइनस j लिखा है. नेक्स्ट R3 ओमेगा C2 एज इट इज, दिस वन मल्टीप्लाइड किया है, मल्टीप्लाइड टू दिस वन कंप्लीट टर्म, दिस इज R3 ओमेगा C2 एंड हियर 1 by j and this j divided by j, that is get cancel, omega will also get cancel here now. So C4 R4 and R3 C4 R4 divided by this C2 is the left term. This equation is left here. Now what we have to do, we have to separate the real and imaginary term here. From this equation, A equation में हमने real and imaginary term को separate करना है अभी. Okay. So I will ask again rule number 12. इसमें रियल पार्ट कौन सा है, रियल इमेजिनरी टर्म कौन सा है? This equation. What is the real term here now? Is it real or imaginary term?
Real.
Real. This one?
Image.
नहीं है. So नहीं है तो
Real.
ये वाला? This one is real or imaginary?
Imaginary.
Imaginary. This one? Real or imaginary? Is there any J term here?
No.
नहीं है. So that is real term here now. इसको क्या करने का अभी? R1 R4 equal to R3 R4 C4 divided by
C2.
C2 लिखने का है. इधर भी R4 है, इधर भी R4 है. R4 गेट कैंसिल हो गए. So R1 equal to R3 C4 divided by C2. लास्ट फार्मूला हो गए.
R1 is equal to C4 upon C2
into R3.
into R3.
So that one we have written here. R1 equal to C4 divided by C2 into R3. ऐसे ही लिखा है ना.
हाँ.
So that is unknown resistance का वैल्यू मिल गया इधर. नेक्स्ट, ये एक पार्ट हो गया, एक फार्मूला हो गया. अभी नेक्स्ट पार्ट क्या है? इसमें इमेजिनरी पार्ट कौन सा है? ये रियल पार्ट है. दिस वन रियल पार्ट का अभी इरेज कर देता हूं मैं. बाकी कौन सा है? अभी इमेजिनरी टर्म्स आर देयर हियर. ओके,
Yes, sir.
I'll shift the camera this side. Okay, so imaginary term कैसे? माइनस J R4 divided by omega
C1
equal to
minus J R3
divided by
omega C2
here now. See here, इधर भी ओमेगा है, इधर भी ओमेगा है, वो दोनों कैंसिल कर सकते.
Yes, sir.
इधर माइनस J है, इधर भी माइनस J, वो दोनों कैंसिल हो गए.
Yes.
सो इधर R4 by C1 R3 by C2 बचा है अभी. ओके, इसको हमने C1 इधर भेज दिया ना, वो क्या हो जाएगा? C1 R3 हो जाएगा.
C1
इस 1 by C1 है ना, इसको इधर भेज दिया तो C1 R3 हो गए.
हाँ. Yes, sir.
इक्वल टू ये C2 इधर भेज देता हूं मैं.
R4
C2 हो गए. R4 C2. सो नाउ व्हाट इज द इक्वेशन फॉर द C1 कैसे लिख सकते हैं आप? C1 इक्वल टू
R4 upon R3 into C2
यही फार्मूला आ गया इधर.
Yes, sir.
So we have identified the formula for the unknown capacitance here now. Measured this is the unknown value of capacitance. Yes, from this equation you can calculate C1 as unknown, you can consider as C2 as unknown. इसमें C1 भी लिख सकते, C2 भी लिख सकते. C2 equal to, can you tell me formula? Roll number 10. अभी C2 का formula बोलो इधर से. Roll number 10.
Yes, sir.
C2 का फार्मूला बोल दो अभी. ये इक्वेशन कंसीडर करके. C2 equal to
C2 equal to
C2 equal to क्या है? ये तो इसका इक्वल टू क्या है अभी?
C2 into R4
इक्वल टू C1 R3 ओनली ना?
नहीं सर,
नहीं है. ठीक है.
So C2 equals to R3 upon R4.
How you will R3 upon
R4
okay
into C1.
into C1. Very good. Only the term it is reversed here now. R4 R3 turns reverse. Okay, that's it. So you learned the things here now. So next what you have to do, we have calculated C1 value, R1 value we have calculated. So in the previous Maxwell bridge, Hayes bridge, Anderson bridge, we were calculating about the quality factor, but for the capacitance में dissipation factor आ जाएगा इधर. The dissipation factor is nothing but previously क्या करते थे हम XL divided by R we can use करते थे. अभी क्या करने का R divided by XC use करने का. For dissipation factor is the ratio of R divided by XC here. So here R1 divided by XC1. XC1 is nothing but omega C1 only, 1 by omega C1. So 1 divided by 1 by 2 equal to 2 only. So omega C1 R1 will get formula here. Now substitute C1 value here. That is R omega as it is. I will keep here now. C1 equal to R4 R3 divided by C2. I have written here. R1 value will go be R1 equal to C4 divided by C2 into R3 here. Now see here. Here R3 is there. Here R3 is there. Term get cancelled here. Yes. Cancel हो गए ना? ये R3 ये R3. Term left is R4 C2 C4 here. So R4 also get cancelled हो गए क्या? नहीं है omega C4 R4. Okay बराबर है ना? Omega C4 R4. This C2 gets cancelled here again. So this omega, this R4 C4. This one we are going to call as dissipation factor. The capacitor will dissipate. For that reason, dissipation factor will come for the capacitor value measurement. Quality factor will come for the inductive measurement. ये MCQ questions आ सकते हैं. This one you have to remember. Therefore, value of capacitance C1 and its dissipation factors are obtained from the value of bridge element at balance condition. The question may come that one. What is the value of formula for the dissipation factor for the Whitson bridge बोल के? Whitson bridge को dissipation factor आता क्या? नहीं है. Only for capacitive bridge it is applicable. Which one we are going to measure for the capacitance, and that condition dissipation factor will be applicable. For the inductive measurement, self-inductance measurement, quality factor will come over there. Okay, so it completes the third unit. This was the last chapter topic of the third unit. So it completed the third unit. If you have any doubts, you can ask. Anyhow, you don't have any classes for our next half an hour. Half an hour break. You can leave other people's, you can leave. Anyone you have the doubt, you can stay in the meeting and you can ask the doubt. Yes, any doubts?
No, sir.
No, then who is having the doubt? Only those people you have to be in the meeting. Other people leave the meeting now. Meeting leave karo. I will check that one. Who will be there in the meeting? I will ask the questions. Other people you can leave the meeting. Only kisko doubt hai? Those people who stay in the meeting. Shrutika, roll number 14. Wagmod is Shrutika. So we'll stop here only and we'll continue in the next class.